I handed it in. I'm just saying I didn't study for my math test.
Dylan, chemistry.
Yeah.
Chemistry. That's done. So think about what the rates are going to do, and then think about what the concentrations are going to do. The previous one, example A, we increased the temperature for exactly the same reaction. Now we're decreasing the temperature. So, why are you so late?
Yeah, Mr. Queen.
Are you in Whittle?
Yeah.
Mr. Queen was there, yeah.
My apologies.
I know, I'm glad you met him, because he's the reason that Privet owns Whittle.
That ain't true.
Explain that.
Yeah, where do you think he was first an assistant in? Privet trained him. Privet trained Mr. Queen.
Then he broke free. It's like,
And his
it's
roots
like,
are deep. He was a house parent in Whittle House for I think since the Ice Age.
Oh, it's like.
And then until he
the
retired,
13
Mr. Gage
colonies
took over.
breaking away from Great Britain, we just became our own
Yeah.
better thing.
Better than anything else.
Only because of the start from Privet.
Loosely inspired.
Loosely inspired.
So you're saying that Willow's better than Privet?
No, I'm saying that all your successes are our successes. We become better when you become better.
No.
So you're rooting for us, right?
Yeah, actually, we are. As long as Ellis doesn't win, I don't really care. I even want Mackenzie to win.
By that logic, Rogers
We don't care about hope.
No, no, no. Through Hope, we own Rogers.
No, that makes no sense.
Yeah. So Hope House was part of Privet when they were in Rogers, which means you had traders inside the house that we
Except
took
that
over.
Miss Hedquist, the house
Also-
parent, was trained by Snow in Rogers.
Oh,
So
what? Oh, yes. Miss Hedquist got her job because I personally and Miss Handley recommended her.
Oh, so there you go.
yeah, but Mr. Snow
Yeah.
trained her.
Mr. Snow has his job
That explains.
because he was first year. He wasn't a house parent, and I said, yeah, he'd make a good house parent because I was a house parent before Mr. Snow. Yeah.
Who was the first house parent?
And Allard is Privet because their color is blue, obviously.
So Privet just rules everything.
Yeah, yeah.
There's no connection to Ellis here.
And that is why Privet.
Yeah, that's why we don't like Ellis.
We
Actually,
don't even want to touch Ellis.
Mr. Barrett
How does it
and
know
Mr. Wismer were both BFAs in Privet House. We own Ellis.
Is that why you're tied with them for third?
Yeah.
Oh.
Honestly, this
I
year,
would literally
everybody should be rooting for Rogers Allard.
We are.
They need to win. Yeah,
Yeah, because they always
Yeah.
lose.
yeah. Then let's not say that. We don't want to say that.
Last year.
Yeah.
Yeah.
No, we came second, didn't we?
Not Ellis lost last year, I think.
Yeah.
That's going to go. Oh, I didn't do
Basically
tense.
won. We basically
Okay,
won.
I am deeply sorry now. I brought up inner house. Everybody's equal.
Yeah.
Start working on chemistry.
Is our test on Monday?
Yes.
We can't beat Privet because we own every house. So no matter who wins.
No,
we win.
Dylan, I'm sorry I brought it up.
Such a good debate, though.
Shh, it's not. We can just quietly know that we're the best. Barry's not here. Everybody else should be, which means we should have 15 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're missing one person. Who's missing?
Chloe.
I don't know where Chloe is. I saw her this morning and she was so excited.
Oh, I should hold it. I'm gonna guess Health Center, but I will send out an email.
Oh, look up. This is so nice. Oh.
Does Chloe send me an email? No. Chloe? Gmail.
I'm just guessing, honestly. I'm just said stress on dioxide. Ready. I don't know.
Why are we starting there, Mr. McFill?
Pardon?
Why are we starting there?
Like, it's a hat. No, go back.
Oh, no, you're there. You're there.
Yeah.
Yeah.
I'm so hungry.
The
Blanket water.
Sleep is more important.
And they,
I had a bowl of dry cereal. I was debating whether to put water in it, but people decided not to.
What, God decided not? That should be a sin.
Harper.
Can we put that in the Bible?
What?
Put Mr. Neufeld,
Thou shalt
is
not.
water a substitute for
no.
milk?
Thou shalt
No.
not
That's
any
criminal.
liquid other
You
than
should be arrested for that. No.
milk.
If you're lactose intolerant, I think water's better than orange juice, which is just unhinged.
Heard of oat milk?
Yeah, for real.
It's
What?
Oat milk is
just put milk in
I
there
know,
and eat it dry.
let's say it's not my choice, but you have no other option.
Then eat it dry.
What is it?
And then have a glass of water that doesn't drain.
Okay. Let's go, 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 go to the gadget machine.
Milk it out.
You just say go go gadget machine?
Yeah. Because we're gadgeting.
So funny.
Ooh! Can I change the example? Probably not as everybody. How many people have drawn something?
I've written one word.
Like 2 people. Okay, let's talk through it. With this reaction, if we decrease the temperature, what are we affecting? Products or reactants? Products. Products because it has the heat term. Are we increasing or decreasing products? It's decreasing. If we're decreasing products, whatever we do, nature tries to undo. Which way could it shift to add more heat back?
Through the reactants.
If it goes that way, it's going to suck up heat.
Oh.
So if we're moving heat, if we move that way, that is the shift, it will actually add heat back to the system. Okay. Another way of thinking, what type of reaction is this? Exothermic. So you get a graph like this. This is the 0.1%. This is an American worker living paycheck to paycheck, and every single cent goes into their health care. They have no money. You give them $1,000, makes a huge difference. They can now get over the hill. If you give the billionaire $1,000, what kind of difference does it make? Nothing. So if we've increased the heat, that makes a huge difference. That was the previous example. We give them $1,000, and then that forward rate went really high. But now we're decreasing it. So now, poor wage slave got a fine for speeding. Take away $1,000. They can't afford their car. They have to sell it. Now they're on the street. Huge difference. The reverse rate here is now even slower. So everything moves to the side. If you decrease the temperature, what happens to the rate? All rates. It slows down. But it'll affect this reverse rate more because it needs heat. So if we're looking at in terms of what happens, if we have, let's go reverse, forward, and then everything, what is green plus blue?
Is that only for exothermic?
It's purple.
Just
Per-
do heat will
Turquoise. Is it only for exothermic, Mr. Neufeld?
He doesn't believe in purple?
Yeah, this is only for exo. You have to look where the heat term is. So an endothermic will have the opposite effect because the heat term is on the other side. So they're both going to drop. Which one's going to drop the most?
The
The reverse, the one with the heat term. So this one drops the most. Boom. That's its rate. The forward rate also drops because of the decrease in temperature, but not as much. Doesn't matter. Top 0.1% doesn't care. For them, $1,000 fine for speeding is just a fee, so they get to speed. Tomorrow we're going to learn all about seizing the means of production. Oh, sorry, did I say that out loud? Now, I already drew it, and then I realized I should probably explain it. As soon as it drops, it's going really slow. But this rate, the forward rate's going really fast, comparatively. If the forward rate's going faster, what is it going to make more of?
more products.
More products. So as it makes more products, what's going to happen to the reverse rate? It's going to increase. So it increases, And then as it loses it, because this rate's going faster, it decreases until once again they're both here. So when they're both there, we know it was an equilibrium here because both rates are the same. And then we know it's equilibrium there because both rates are the same. And I'll make it so that they're the same. It's purple because I don't know what blue and green make. Probably some sort of brown. Is it teal? That's just another form of blue.
But if you just
We have this
So what you're saying is that blue overcomes green to be another form of blue. I love
They
that.
they
I
form
love
an
that.
equilibrium.
But if you just picked blue and red, this would be so much easier. You could just make
And
it
that could just,
purple.
oh,
And we
that's,
wouldn't have this argument
that-
every time.
that would be smart. Okay, so this was the same as removing in product, decrease in product. The stress shifts the equilibrium to the,
Reactants. Wait.
Product.
Products.
product. Not because one of the rates was so much faster, but because one of the rates was so much slower. Yes.
Why would it lead to a decrease in products? If there's less heat, then less products would be able to go back into.
We're not looking at the speed at which the products are made. We're looking at the amount the equilibrium shifts. So they are being made slower. But because this is this is an endothermic, we reverse everything I was saying. But this is the side with the heat, so that is the lowest side. It needs the most energy. We've taken energy away. This rate, this reverse rate, now slows the most. It goes
So
further.
then there should be more products. No?
If this rate slows, so it's not pushing back very
I
hard,
see. And then the other way is
then the other way is faster, it's going to make more product.
So then why did you write the decrease in products?
Oh, this shift, decrease in temperature, is a decrease in heat. So here I'm not talking about how it's shifting, I'm talking about the shift, like what we did. We decreased the
Heat
heat.
the product?
Heat is a product, yeah, it's an exothermic reaction.
How?
Yeah.
But there's also an increase in AB, so.
Yeah, there is. So, yeah, that makes sense. It would be confusing. Heat is a product. But then after, as we let it go to equilibrium, there's going to then be an increase in AB. There's also going to be an increase in heat, because heat is an exothermic reaction. We're going to get more reaction out. Now, you should be able to do a guess of
Wait.
if...
What about the thing before heat? You can fill that out.
Didn't I?
No, you didn't.
I think you could probably fill it up.
More.
To create
More heat.
more heat, sure. More. No. More. Now graph what you think these curves will look like. Do they go up? Do they down? Are they straight lines? Are they curves? Knowing which way it shifts.
Oh, I know.
What happens to all those things? You can look at your previous graph. It should probably inform.
Wouldn't they just go like straight out and then technically it should probably be parallel?
Oh, am I actually recording? Just double check on the live streaming. I am in fact live streaming. Woo-hoo!
I did my job.
Okay, I didn't change the reaction, did I? I did not. Okay. What is A going to do?
It's gonna go down.
It's going to go down. And what will that down look like?
Like that.
Ah, I like the way you drew that. You like that, right?
Oh no.
No. Excellent. Why not that?
Because
It's gonna go
that makes no sense.
It's gonna go down quickly at the start.
Down quickly and start. So it's essentially just that part of the graph. We often draw it like it'll be often quick, so you could also draw it like a little bit down, a little bit faster. But the particular slope doesn't matter as long as it's fastest there. So it should be a sharp curve. I went around, I think I corrected a few people the other day. They were drawing their curves like that, which is why I wanted to bring it up. This implies slow change, fast change, slow change, which is, that's a very good like pH curve, but it's a very poor rate curve because it should be fast change, slower, because the concentrations change most quickly at the beginning, and then as they get to equilibrium, it slows and slows and slows until they're always the same. So let's get rid of that. Get rid of that. Go away. Go up. Go up. Exit. What will happen to concentration of B?
Same as A.
Same as A. And in addition to being the same as A, if this distance here is x, then the amount that this goes down should also be x. If I go like that and that, those should be dotted lines. Maybe I should use a different color because the actual graph is there. If I just put them up, those distances are the same because although their concentrations could be anything, the amount they change is determined by their stoichiometric ratio. And I'm using a 1-to-1-to-1 ratio, which is why I initially said, can I change the reaction? I was about to make it a different. I think the next reaction we have, I'll either change to illustrate that point. But since they're all a 1-to-1-to-1 ratio, the depths of their curve should all be the same. So how much should AB, which direction should AB go?
Up.
Up. And it should do it by the same amount. This distance here should be the same. All those distances should be the same. It's a 1-to-1 ratio of
Wait, I
reaction.
have a question. If mine doesn't cross, does that matter?
No, it depends on how you drew them. If you drew them more shallowly, because we don't have numbers with this,
Oh, okay.
then it
So
may
you
not
technically
happen.
don't even-
As long as they're roughly the same and they look the same, that's fine.
Okay.
Okay. And they have that sharp curvy bit. Good. Okay, first type of change we did. First type of change, we changed the temperature. We increased it, we decreased it only for an exothermic, but the logic still applies. You can work through it for an endothermic. Your head will really explore that. In this one, we're going to change the concentration. So I am just adding A. Just so the concentration of this goes up. Which way does it shift? To the product. So it goes this way. That went up. Concentrations are higher, so it shifts that way. When this went up, which rate increased?
Rate of reaction.
The reaction. The reaction.
Forward or reverse is what I'm looking for.
Forward.
Forward. And then as we shove more stuff to the other side, what will happen to the reverse reaction rate?
It also
It will also increase. What will happen to this rate as we shove things to the other side?
Decrease.
It'll start to decrease.
Wait, what? It increases, then it increases, then it decreases?
It increases, and then the forward rate decreases because it increases and it starts shoving things to the other side. And then as more, and
Oh,
that
as
means
more
there's
stuff
less of it.
adds,
Yeah, and
so
then
there's less there, so it goes like.
yeah.
Yeah. Oh, okay. I see.
So it shifts to which side?
To the product.
Product side. To what does it do to A?
It decreases the.
Sure, decreases sounds good. There used to be 3 words there,
Are you saying?
and what they are has been lost to the mists of time.
Make it small.
It just make it smaller would work. Yep.
side to make it smaller.
A. It's very Canadian. Make it smaller, eh? Okay. Determine what the concentration of BA and AB will do, and then graph it. You've got a graph here. This graph is to be time and rate. So you've got all that. I'm going to come around and look, see what you're doing. Fill those up first. Figure out the direction. You got the direction. A hint is that none of them will be the same. But when you increase that, what happens to the forward rate? What happens to the amount of B once the forward rate increases? Yep.
But then not all of them.
I think I.
Well,
Oh.
A is kind of tricky. Because A doesn't just increase.
How do you know that?
Oh, don't do that. Because that looks like an
It's probably
activation.
gonna laugh at me. I got it.
No, it's like increasing and then.
Oh, I see what you, okay. How we represent, when we add, you know how physics pretends there's never any friction?
I learned physics.
But like grade 10 physics you did. Did we not just, you didn't?
A long time ago.
Long time, okay. We added A. So one of the things that happened with A is it went along, and this is, let's say that's T1, where the event happened, whatever it was. And here's A. And then we added A. What would that look like on the graph?
So instant.
Instant, so it would be a spike. So it increases.
Oh, and then it goes.
And then it goes down. Oh, hold it. And keep in mind,
Increases.
this is not the same reaction as before. This is 2B and AB2. It is in a 1-to-1 ratio. That will be important.
B should decrease.
So A should increase, decrease. It should go like
Wait, what?
that.
That's not what I
Because when we add something, we always assume it's instantaneous, so it spikes.
So then B would be half of the like curve of A. 'Cause it's-
Well,
Or it'd be
it
twice this.
would be twice. So if this is, do it in a different color. If this is X, by how much should B go down? 2X. So B should go down, oh, I didn't mean to quite, but that is about what 2X would be.
God, this is terrible.
And then what should AB do?
AB should go up because it increases, but
Up.
it should go up by X.
It should go up by X, so it will go up just the same amount. And that amount,
Okay, I got AB right.
which would look like that. So when we increase or decrease a concentration, there's spikes. And here's, just to give you an example, here's how we ask questions about it. If I say, because concentration of B is easy, what happened to the concentration of B?
Decreases.
Decreases. And if I say, what happened overall to the concentration of A?
Increase and decrease.
Overall, what happened to it?
Increase.
If I measure the beginning, I measure the end, I would just say it increases. So first A spikes, and it will stay higher than it ever was overall, because no matter how much it goes down, B is also going down and affecting the rate of reaction. It will never go below what it originally was.
Why not?
In terms of the amount that you add, you've added more to the system. And so now we're going to use up B. B is going to get even less and less and less and less. And since you've added more, the reverse rate's now going to increase. You'll never get back to that point. You'll have a new ratio. We haven't done K and Q yet. When we do, you can see it mathematically.
said
But
A.
that ratio is a fixed constant.
It's an A increase. It could have increased by like one molecule.
Yeah, could be. Because you could have increased it by a tiny little bit, let's say like 10 molecules. Sure. But if I said, what happens to the concentration of A as it approaches equilibrium? Decreases. So a lot of the phrasing of questions depends on the time that they're talking about. If they're talking about overall, it increased. If they talk about when they added it, it spiked. If they're talking about as it approaches equilibrium, which is a lot of what they do, is it'll say, oh, well, it decreased as it approaches equilibrium. Sometimes students will go, wait a minute, but it increased and then decreased. Yeah, but they said as it approaches equilibrium, that is implying after the change.
Wait, so it decreases as it
So it spikes. Yes?
decreases as it approaches equilibrium?
Yep.
Oh.
And what does the concentration of AB do?
Increase.
Increase. I think there's a question that, like, why won't it ever go below? Let's say that you just made this a ratio. You just took the concentration of AB and you put it over the concentration of A and the concentration of B. We're going to do this later. You'll find out that's a constant. And when you change one of those, the other ones will change until you get the same number. And, and you'll learn how to make those. This is actually slightly a lie, because if I was to do that, I'd have to square B. There's a little bit of calculus involved for the reasons why you square that. But that's the next unit. Never mind. Now, what happens to the rate? We have, I will pick, we have, what'd you say, red and blue?
Yeah.
So forward is going to be red, blue is going to be reverse. So we got the forward, oh right, forward and reverse are purple. That doesn't look purple. There we go, purple, forward and reverse. If we increase A, what happens to the forward rate?
It increases.
It increases. So we get a spike. When we increase A, what happens to the reverse rate?
It also increases
Why?
because there's more AP to be turned
Is-
into.
Right at the beginning, when we added A, is there more AB?
There's none.
There's none. So there's no spiking with the reverse. And you're like, what happens after that? Then, yeah, then it goes up.
Just like a curve upward.
So it'll curve upward, because what's going to happen to this rate? It's going to start throwing AB to the other side. What will happen to the forward rate as it uses up A and B?
Slow.
It's going to slow and it's going to go down. And then the reverse rate is going to get more AB, and it's going to speed up and then slow down until they once again meet in holy matrimony and kiss.
That was interesting.
Trying to make that curve look good, and I don't think I'm doing a good job. Better. Excellent. Anything I'm forgetting on here? Do you think so? Concentration change. Excellent. Excellent. Good. On this page, do the concentration. I don't know why, but apparently I gave you a whole page to do the rate. It's this reaction. So, same reaction, increase the concentration of B instead, graph it,
Is it instead?
and then rate it. Okay? So it's A plus 2B goes to AB2 plus A plus 2B goes to AB2 plus.
Are we also doing A? Also increasing?
Nope, just concentration of B increase.
We already did this graph.
No, we did it with A. Now we're doing it with B.
Oh.
Because I wanted you the chance to do it on your own. Yeah. Do you think so? That's okay. Because it takes a little bit sometimes to come to it. If you increase the amount of B, what would that do to the forward rate? Increase it, sure. And then what will that look like if you increase B on the graph?
What happens then? Increase this?
Spike?
Huh?
And then start working up what do all the other ones do.
History of health?
No, it's do I have be that
Bro, so what do we do with A?
Why is A reacting 2 times more than 2?
Oh, B should be reacting 2
times more than
A.
Yeah.
Wait.
Or A is half of B, whichever you want to think of. Because it's always 2B.
But A is decreasing, B is
Then I'm just
increasing.
pretty much drawing what the.
No.
You have them both.
Yeah.
No, B
Right.
is increasing.
B increased, and then as it approached
It
equilibrium.
That's right.
That's right, yeah.
Yeah.
Mr.
B goes up and then goes down.
Since B increases, that means
Oh, but B should be
it will
twice
A
as much
increase
as A.
too.
Will it?
Just half as much.
Why did B increase?
Because you said it.
Because I said it did. So once we increase B, what will happen to A?
It also increase.
Will it?
Or because there's gonna be more stuff to react.
And what will, if there's more B to react with, what will happen to the amount of A? If it's reacting,
Increase faster.
it will decrease faster. Yeah. Ta-da! Those look good. I did do that so that they could be the originals and you show the change. But that's fine, that's fine.
Did I do it?
B is 2 times more. Oh, the amount that B changes is not from there, it's from there.
Oh,
So it has to go down twice as much.
so from here to here is too much?
From there to there, yes.
Oh.
Your spikes are really curvy, just make them spikes. Yep, instantaneous, boom, goes down, and it goes down by 2x, that's perfect. And not from up, there.
Yeah, yeah,
Yep,
that's what I'm.
yep, and then and then turn it over, do that one. That's the rate for the same hash. As soon as you do it, turn it over, do the rate for the same one.
Is this
But
right?
it's A, B the same.
We go like that and
Yeah, that's a lot of B, but sure, yeah,
we added what we added.
sure, yeah, that can work.
Wait, but could it be like this? Wait.
But hold it, but the amount isn't 2x from there. The amount it drops is twice as much. Because it's reacting, so we spiked it, you don't know by how much, so you just said, oh, we did a lot. But now the amount that goes down has to be twice what A goes down. You actually have it slightly less. It should go boom, boom.
Oh, so it should be like, it should kind of go like there.
Yeah, yeah,
Okay.
maybe.
I kind of just.
Everybody's graph can be a little bit different.
Yeah, that's to decrease more.
So that.
I just made it spike.
Isn't it the same as when you increase A?
It will be after B is added. Yeah.
So it will also increase and then decrease, does it?
Will it increase? Like increase and then decrease? What will the forward rate do?
I don't think that would
Like,
So, yeah, because you spike B, so what will the reverse?
No, I just made it spike. Which you
So
can do.
mine's the same thing, but yours is the.
The other one's spike,
As
have you
long
drawn it?
as-
Turn over the page and draw.
This is twice.
Is this right? With the.
I'm about to do it on the board. I think I'm gonna go do it on the board. There's a couple I haven't seen at all. You've got that, which one's B? B should go down by 2x, cause it's 2B.
Oh, okay. I thought it was just because.
But you have it, like, you're measuring the right kind of area? Okay,
Or does it go like this?
if B increases, you have A,
does the other rate increase?
and you have B. B increases, how do we show that?
It goes up.
Spike. And then it goes down. Whenever it goes down, this is where you're measuring how far. It should go down twice as much as A. So let's say it goes down that far. Then, let's get a dashed line. There we go. Dash that line. Bam. That means that, whatever it is 2x. However amount A goes down, Really, half of that should just be 1x. And A doesn't spike because we didn't add any A. It just B went up, and then the forward reaction rate increased, used up B and A, B twice as much, and then shoved it to the other side. And if it's shoving it to the other side, what happens to the amount of AB? It increases by X. And that is a terrible representation of X. That looks like 2X.
Mr. Newfound,
Yep.
I did for B it increases by X, and then by A and B they A decreases by half X and AB increases by half.
Yeah, well, half, and 1 is the same as 1, 2, and 1.
So I can do that?
Yeah?
Okay.
I'm just explaining what their relative ratio should be. So I'm making it 1x, 2. I mean, you could say that's 2x, 4x, and 1x. I just don't tend to use fractions when we talk about balancing, but there's no particular rule when we're doing it down there as opposed to up there. Good? So what happened to the forward rate when we added B?
Increase.
Increased. What kind of increase? Curve or a spike? Spike. So over here, I'm once again going to go, let's make forward blue, reverse red, purple normal, and so forward room 1 spikes the highest. And does a reverse rate spike? No. But what happens, it's the forward rate spike, it's throwing to the other side. What is, once it's throwing to the other side, what's going to happen to the reverse rate? Increases. And the forward rate is going to, and they're going to meet in the middle and kiss. And then it goes back again. Good? Good. Did that, hold it. Forward reaction rate, reverse reaction, what for A, because what happened, we did that the next page. We did that. Volume changing. What happens to the, decrease the volume, what happens to the pressure?
It decreases.
Decrease, I got a decrease, I got an increase. This sounds like it needs a demo.
Increase in pressure. Because less
Wait,
volume.
you give less volume. There's less pressure.
Oh wait, no, there's more pressure because there's less area. It's like more stuff.
Oh, like
but
volume
in a
is like
smaller
Think of
container?
like volume of container.
Oh.
I thought you meant volume.
Yeah, I thought you meant volume of gas.
Yes,
Yeah,
gas
same. Okay.
pressure increases.
There's more
Why not?
container, there's less room for the stuff.
But if
Or there's more
it
room for
is
stuff.
gas, then there's gonna be less pressure.
What?
Because there's less pressure.
Yeah, it'd be. Oh, it's to give a pop balloon more pressure.
So just blow it into the box.
So this balloon has a certain amount of pressure in it. If I decrease the volume,
Volume of what? The container or the actual
Container, the
the
gas.
container,
And the pressure.
Then the pressure.
Oh my god, more pressure,
What's-
there's more pressure, there's more
what's gonna
pressure!
happen? Sabine, just so you're aware. What's going to happen? What's happening is I decrease the volume.
Increase.
Pressure increases. And you all instinctively know that. So when the question comes up, you just remember the balloon, because as you decrease the volume,
You're like, you don't just massage it.
everybody's just wincing so much.
What if you pop the balloon with a needle?
Ready, ready?
Yeah.
These are right next to it.
Why'd you scream?
Sometimes it's frightening. Okay, we decrease the volume. What happens to the pressure?
Increase.
Increase.
Was it loud?
What gases were in that balloon?
Nitrogen.
Nitrogen,
Oxygen.
oxygen,
Carbon
carbon dioxide. There's 3 gases there. Which one's increased in pressure? All of them. So it increases the concentration of all gases present. So every single one of them increases in concentration. So when you're changing the volume of the container, you're going to get multiple spikes. They're all going to change concentration. Now, I can't take a balloon and suck it open, but if you've ever played with a syringe, like you put it against your finger and you open the syringe and you create a vacuum, you're doing the same thing. Or that terrible prank that some people play on people where they put like half of a squash court ball sucked in on their head.
No one's ever.
I don't know what that
Like
is.
a common prank that people play.
Like I know what'll happen. It'll create a huge well.
Create a section. Yeah. I'm glad nobody has heard of that. Well done.
Like
I've heard of it before, it's just no one else did it.
Pardon?
It's gonna happen.
Yeah, now that I put the ideas,
People's heads and then push
finally
it.
nobody had ever thought of it.
So it creates this massive like,
What is a squash ball? What is squash? Like,
bro.
We have
oh,
squash
like the
courts.
thing they play-
Yeah,
okay.
okay. It's okay. You're probably thinking of the food?
No, yeah.
So we increase the volume, what happens to the pressure?
Increase volume, decrease
Decrease the pressure. And then what happens to the concentration of all the gases if we decrease the pressure?
It decreases.
Decreases. Decrease concentration of all gases present. Thank you.
But if there's nothing else like in the container, how does it decrease? Oh,
Because concentration is particles per volume.
right.
If you increase the volume, there's just more volume per particle. Yes. We also. So the forward rate spikes, but as it approaches equilibrium, forward rate spikes and then decreases.
Oh, so should I say overall?
So I would say spikes. Yep. And then decreases. That's not equal.
No, but we just started a new thing.
And that one's just increasing.
The volume that's
Mr. Neufeld, will there be like gases everywhere on the thing? On the grid?
No, it's only PO of D. This is E. So if you go and practice old exams, D question.
Thanks, Jeff.
What would do? This, all of this. No, this is E.
This is E.
This is D about the.
Where's, oh, it's on the other page. If I can bring it up.
I already forgot that.
What? You're getting a shot.
D. Oh, let's call it up. D was the introduction to equilibrium.
The blue one, you would be serious.
No, the meningitis.
Yeah,
is
but
shot.
it had like we're doing now shifting and graphing and everything else. This,
It's a muscle shot.
D was
But is
the
there
in,
not
like
muscle shots?
the what is a dynamic versus a static equilibrium.
Some go farther in than
Oh.
others.
Yep. Yep. So we did the wall of equilibrium lab. We looked at a lot of delta H, forward and reverse.
Oh, that was like entropy and entropy.
Yeah, entropy and enthalpy. Which way is spontaneous? Which way is it not going to go? Maximum and minimum entropy and
It
enthalpy.
makes me nervous.
Delta S.
And I'm like, oh,
Where is stuff going to happen?
this feels like
Boom, 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 boom.
slithering it down your arm. Like,
And then combining both of them. I think that's what I was already applying. And then finish off with that. And do some old D questions, and you'll see all those come out.
Nice memory.
Yes. Were you here in the, on test day?
No, like overall grade. I've seen
Oh.
the best grade.
Do we have a break now?
No, but I was just wondering, is that like a quick thing or not really?
Well, I don't have it in as a grade because I'm not entering the grades. Like, if you want the grade in your test, I can tell you what you have overall in my
Have you
workbook.
marked the labs?
No, I'm not done marking the labs. I haven't even
So-
started marking the labs.
You can tell us what our overall. Is.
When I go to put them in, that's when I'll do the things like replacing all your old marks and make sure that's all
You should mark
good.
the labs out.
Because if we do another test
Lab,
before your next grade thing, I'm going to do that all again anyway.
So you can tell us now.
A
Probably
grade
gonna check
that
out.
may or may not be. What I tell you now is your minimum possible grade.
Okay, then can I?
Sure.
Yeah,
Which mark book?
What?
What?
Well, I take your highest grade from the traditional mark book and